Imagine strolling through a park on a crisp autumn day. The leaves are changing from green to shades of yellow, orange, and red. The temperature, too, is changing. It's a continuous change, sliding from a chilly morning to a warmer afternoon, then back to a cool evening. It doesn't instantly jump from one temperature to another. This is a real-life example of continuity, similar to the concept we explore with the intermediate value theorem in calculus. The intermediate value theorem, or IVT, is a fundamental concept in calculus. It connects the dots, so to speak, between the continuity of a function and its output values. The theorem states that if f is a continuous function over a closed interval from a to b, and k is any value between fa and fb, then there must be at least one point c in the interval from a to b where fc equals k. Think of it like this. Picture a curve that represents a function f. Starting at point A with an output of fa, move along the curve to point B, where the output is fb. The function must pass through every value, k, between fa and fb, at some point along the way. There will be a corresponding input c within the interval where the output is ek. There are a few key points to remember about the intermediate value theorem. Firstly, the function f must be continuous on the entire closed interval from a to b. This means there can't be any jumps, holes, or gaps in the graph of the function. Secondly, while the theorem guarantees the existence of at least one c, it doesn't tell you how many such points there might be. Finally, the IVT has various applications, such as proving the existence of roots or zeros of functions, analyzing continuity, and studying intermediate values. For example, consider the function fx equals sine x squared on the interval from 1 to 4. The output at f1 is 1, and at f4 is 16. Since 9 falls between 1 and 16, the IVT guarantees that there's a point c between 1 and 4 where fc equals 9. On the other hand, the function fx equals sine sins on the interval from 0 to pi doesn't quite work with the IVT. The output at f0 is 0, and at fpi is also 0. Even though 0.5 is between 0 and 0, the IVT doesn't apply here because sin x isn't continuous on the entire interval. There's a jump discontinuity at pi over 2. In conclusion, the intermediate value theorem is a powerful tool in calculus that helps to link continuity with output values. It's essential to remember the conditions required for it to apply, namely, the function must be continuous over the entire closed interval. It's also important to remember that while the theorem guarantees at least one c, it doesn't tell you how many such points there might be. Finally, keep in mind that the IVT has numerous practical applications, from proving the existence of roots of functions to studying continuity and intermediate values.